I'm Blaine Sunder with AWS Training and Certification. I've been teaching technology for more years than I'm willing to admit. After spending time teaching the newspaper industry, I moved to AWS, where I've taught classes globally on many different disciplines, such as security, cloud architecture, DevOps, big data, AI and ML, and theater history. My mama was a teacher. My daddy was a teacher. My grandpa was a bartender. I was born for this.
Hi, I'm Morgan Willis, a senior cloud technologist at AWS. I started in the IT world about 10 years ago, and along the way, I decided that I was missing something. I missed the helping and teaching aspect of IT that I had in my first job in IT support. So I went into teaching software development in different areas around the US, and then I eventually landed here at AWS, where as a cloud technologist, I get to support others in their cloud journey every day.
And I'm Rudy Chetty. I come from sunny Cape Town, South Africa, home of Biltong, Boerewors, and Bunny Chow. I'm a solutions architect and have been with AWS for over 3 years. Teaching is my passion, and I can't wait for you to dive into the course and learn. And Giabonga Gakulu, feels geluk, thanks a lot, and good luck.
This course is going to cover all the essential information that you need to understand to be comfortable discussing AWS, to know why it's beneficial to your business.
AWS offers a massive range of services for every business, starting with basic elements like compute, storage, and network security tools, through complex solutions like blockchain, machine learning, or artificial intelligence, and robot development platforms, all the way through very specialized toolsets like video production management systems and orbital satellites you can rent by the minute.
All that, however, is way more than we have time to cover in a foundational class like this one. So let's simplify the conversation by starting with the fundamental cloud compute model.
Almost all modern computing centers around a basic client-server model. Now, I know it can be more complicated than that, so let's take a look at our coffee shop.
This coffee shop is going to give us some real-world metaphors to help you understand why AWS can change the way your IT operates.
Let's make Morgan the server, the barista, and I am the client, the customer. I make a request. In this case, it is for coffee. Now, in the computing world, the request could be anything. It could be rain pattern analysis in South Africa, or the latest x-rays of your knee, or videos of kittens. Whatever is the business. Basically, the customer makes a request, and with permissions, the server responds to that request. All I want is a caffeinated beverage. Morgan represents the server part of the client-server model. In AWS, she would be called an Amazon Elastic Compute Cloud, or EC2, an EC2 instance, a virtual server. So from an architectural point of view, the transaction we did is really simple to explain. I, the user, made a request to Morgan, the server. Morgan validated that the request was legitimate. In this case, did I give her money? Then she returned a response, which in this case is a berry blaster with extra caramel shots.
Now, in the real world, applications can get more complicated than just a single transaction with a single server. In a business solution that is more mature, it can get beautifully complex.
To avoid this complexity, we're going to start simple. We will build this discussion out so it is easy for anyone to understand how these concepts build on each other. So by the end, those complex concepts, they'll be easy to understand. Let's start with a key concept to AWS, and that is you only pay for what you use.
This principle makes sense when you run a coffee shop. Employees are only paid when they're in the store working. If Rudy or Morgan are off the clock, well, then they don't get paid. The store owner simply decides how many baristas are needed and then just pays for the hours they work. For example, the coffee shop is about to release a new drink, the Pumpkin Monster Spice. In anticipation of this launch, you could always staff your shop with a dozen baristas all day long, just in case you suddenly get an unexpected rush at some point in the day. Only, let's be honest, for most of your day, you don't have near enough customers to justify paying for all those employees.
And yet this is exactly what happens in an on-premises data center. You can't just snap your fingers and triple your capacity. At AWS, you don't prepay for anything, and you don't have to worry about capacity constraints.
When you need instances, or baristas, you just click a button and you have them. Then when you don't need them, another click, and they go away, and you stop paying for them. The same way you don't pay for employees for hours that they're not working.
So pay for what you need becomes the first key value of many for running your business on AWS. And that is really why we're here, to help you understand how AWS is built to help you run your business better.
We hope you stick around for the entire course as we dive deeper into these concepts and help launch you on your journey towards being a cloud practitioner.
Before we get deeper into the pieces and parts of AWS, let's zoom out and get a good working definition of cloud. Cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So let's break this down. On-demand delivery indicates that AWS has the resources you need when you need them. You don't need to tell us in advance that you're going to need them. Suddenly you find yourself needing 300 virtual servers? Well, just a few clicks and launch them. Or you need 2,000 terabytes of storage. You don't have to tell us in advance. Just start using the storage you need when you need it. Don't need them anymore, just as quickly you can return them and stop paying immediately. That kind of flexibility is just not possible when you're managing your own data centers. The idea of IT resources is actually a big part of the AWS philosophy. We often get asked why AWS has so many products, and the answer is really simple, because businesses need them. If there are IT elements that are common across a number of businesses, then this is not a differentiator. Take a MySQL database as an example. If your business runs a MySQL database, does your ability to install the MySQL engine make you a better company than your competitors? Well, probably not that. Do you keep backups in a way that makes you superior to other players in your vertical? Again, doubtful. The data inside your database, now that's critically different. The way you build your tables and manage the structures absolutely separates you from the competition. But the engine is just the engine. At AWS, we call that the undifferentiated heavy lifting of IT. tasks that are common, often repetitive, and ultimately time-consuming. These are the tasks AWS wants to help you with, so you can focus on what makes you unique. Over the internet seems simple enough, but it implies that you can access those resources using a secure web page console or programmatically. No additional contracts or sales calls are needed. With pay-as-you-go pricing, we re-emphasize what we pointed out here in the coffee shop. You don't staff a shop with employees 24 hours a day at the same levels you do during peak hours. In fact, some hours you might not even staff them at all. So why pay for developer environments, for example, on weekends if your developers aren't working on the weekends?
In this video, we are going to talk at a high level about a service called Amazon Elastic Compute Cloud, or EC2. If you remember from our coffee shop, the employees are a metaphor for the client-server model, where a client sends a request to the server does some work, and then sends a response. That example is for the coffee shop, but the same idea applies to other businesses. Your business, whether it be in healthcare, manufacturing, insurance, or delivering video content to millions of users all around the world, are also using this model to deliver products, resources, or data to your end users. And you're going to need servers to power your business and your applications. You need raw compute capacity to host your applications and provide the compute power that your business needs. When you're working with AWS, those servers are virtual, and the service you use to gain access to virtual servers is called EC2. Using EC2 for compute is highly flexible, cost-effective, and quick when you compare it to running your own servers on premises in a data center that you own. The time and money it takes to get up and running with on-premises resources is fairly high. When you own your own fleet of physical servers, you first have to do a bunch of research to see what type of servers you want to buy and how many you'll need. Then, you purchase that hardware up front. You'll wait for multiple weeks or months for a vendor to deliver those servers to you. You then take them to a data center that you own or rent to install them, rack and stack them, and wire them all up. Then, you make sure that they are secure and powered up, and then they're ready to be used. Only then can you begin to host your applications on top of these servers. The worst part is, once you buy these servers, you are stuck with them, whether you use them or not. With EC2, it's much easier to get started. AWS took care of the hard part for you already. AWS already built and secured the data centers. AWS has already bought the servers, racked and stacked them, and they are already online, ready to be used. AWS is constantly operating a massive amount of compute capacity, and you can use whatever portion of that capacity when you need it. All you have to do is request the EC2 instances you want, and they will launch and boot up, ready to be used within a few minutes. Once you're done, you can easily stop or terminate the EC2 instances. You're not locked in or stuck with servers that you don't need or want. Your usage of EC2 instances can vary greatly over time, and you only pay for what you use, because with EC2, you only pay for running instances, not stopped or terminated instances. EC2 runs on top of physical host machines managed by AWS using virtualization technology. When you spin up an EC2 instance, you aren't necessarily taking an entire host to yourself. Instead, you are sharing the host with multiple other instances, otherwise known as virtual machines. And a hypervisor running on the host machine is responsible for sharing the underlying physical resources between the virtual machines. This idea of sharing underlying hardware is called multi-tenancy. The hypervisor is responsible for coordinating this multi-tenancy, and it is managed by AWS. The hypervisor is responsible for isolating the virtual machines from each other as they share resources from the host. This means EC2 instances are secure, even though they may be sharing resources. One EC2 instance is not aware of any other EC2 instances also on that host. They are secure and separate from each other. Luckily, this is not something you yourself need to set up, but it's important to know the idea of multi-tenancy and have a high-level understanding of how this works. EC2 gives you a great deal of flexibility and control. Not only can you spin up new servers or take them offline at will, but you also have the flexibility and control over the configuration of those instances. When you provision an EC2 instance, you can choose the operating system based on either Windows or Linux. You can provision thousands of EC2 instances on demand, with a blend of operating systems and configurations to power your business's different applications. Beyond the OS, you also configure what software you want running on the instance, whether it's your own internal business applications, simple web apps, or complex web apps, databases, or third-party software like enterprise software packages. You have complete control over what happens on that instance. EC2 instances are also resizable. You might start with a small instance, realize the application you're running is starting to max out that server, and then you can give that instance more memory and more CPU, which is what we call vertically scaling an instance. In essence, you can make instances bigger or smaller whenever you need to. You also control the networking aspect of EC2. So what type of requests make it to your server, and if they are publicly or privately accessible is something you decide. We will touch more on this later in the course in detail. Virtual machines are not a new thing, but the ease of provisioning EC2 instances allows for programmers and businesses to innovate more quickly. AWS has just made it much, much easier and more cost-effective for you to acquire servers through this compute as a service model. There's a lot more to learn about EC2. We talked about virtualization and the types of software you can run on an EC2 instance, but there is more you can configure with EC2 as well.
Now that we've learned about EC2 instances and the crucial role they play in AWS, let's talk about the different types of EC2 instances that are available. Thinking back to our coffee shop analogy, you'll remember that EC2 instances are like our employees in that they serve client requests. If we want to have a cafe that can serve a lot of customers, then we're probably going to need multiple employees, right? And they all can't just be cashiers. We also need someone to make the drinks, someone to handle the food, and maybe someone to do that cool latte art that our customers love so much. Like any business, there are a variety of tasks that need to be done, and they often require different skill sets. If we want our business to operate as efficiently as possible, it's important to make sure that an employee's skill set suits their role. In the same way that our coffee shop has different kinds of employees, AWS has different types of EC2 instances that you can spin up and deploy into your AWS environment. Each instance type is grouped under an instance family and are optimized for certain types of tasks. Instance types offer varying combinations of CPU, memory, storage, and networking capacity and give you the flexibility to choose the appropriate mix of resources for your applications. The different instance families in EC2 are general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. General purpose instances provide a good balance of compute, memory, and networking resources and can be used for a variety of diverse workloads like web servers or code repositories. Compute optimized instances are ideal for compute intensive tasks like gaming servers, high performance computing or HPC, and even scientific modeling. Similarly, memory optimized instances are good for memory intensive tasks. Accelerated computing are good for floating point number calculations, graphics processing, or data pattern matching as they use hardware accelerators. And finally, storage optimized are good for, can you guess it? Workloads that require high performance for locally stored data. Now, if we map this back to our coffee shop, our cashier becomes a memory-optimized EC2 instance, baristas become compute-optimized instances, and our latte art employee is an accelerated computing instance type. And there you have it, EC2 instance types. We talked about EC2 instance types, but you're all probably wondering, how much is this going to cost me? Well, don't fret. For EC2, we have multiple billing options available. The first one, and the one that most people are familiar with, is called on demand. What that means is that you only pay for the duration that your instance runs for. This can be per hour or per second, depending on the instance type and operating system you choose to run. Plus, no long-term commitments or upfront payments are needed. This type of pricing is usually for when you get started and want to spin up servers to test out workloads and play around. You don't need any prior contracts or communication with AWS to use on-demand pricing. You can also use them to get a baseline for your average usage, which leads us to our next pricing option, Savings Plan. Savings Plan offers low prices on EC2 usage in exchange for a commitment to a consistent amount of usage, measured in dollars per hour for a 1 or 3 year term. This flexible pricing model can therefore provide savings of up to 72% on your AWS compute usage. This can lower prices on your EC2 usage, regardless of instance family, size, OS, tenancy, or AWS region. This also applies to AWS Fargate and AWS Lambda usage, which are serverless compute options that we will cover later in this course. Another option is reserved instances. These are suited for steady-state workloads or ones with predictable usage and offer you up to a 75% discount versus on-demand pricing. You qualify for a discount once you commit to a 1 or 3 year term and can pay for them with 3 payment options. All upfront, where you pay for them in full when you commit, partial upfront, where you pay for a portion when you commit, and no upfront, where you don't pay anything at the beginning. The next option is spot instances, and they allow you to request spare Amazon EC2 computing capacity for up to 90% off the on-demand price. The catch here is that AWS can reclaim the instance at any time they need it, giving you a 2-minute warning to finish up work and save state. You can always resume later if needed, so when choosing spot instances, make sure your workloads can tolerate being interrupted. A good example of those are batch workloads. And finally, we have dedicated hosts, which are physical hosts dedicated for your use for EC2. These are usually for meeting certain compliance requirements, and nobody else will share tenancy of that host.
So we have a good idea now on the basics of EC2 and how it can help with any compute needs, like making coffee, or like metaphorically making coffee. The coffee represents the whatever your instance is producing. The next thing we want to talk about is another major benefit of AWS, scalability and elasticity, or how capacity can grow and shrink based on business needs. Here's the on-prem data center dilemma. If your business is like 99% of all businesses out in the world, your customer workloads vary over time, perhaps over a simple 24-hour period, or you might have seasons where you're busy and weeks that are not in demand. If you're building out a data center, the question is, what is the right amount of hardware to purchase? If you buy for the average amount, the average usage, you won't be wasting money on average. But when the peak loads come in, you won't have the hardware to service the customers, especially during the critical moments you expect to be making all your results. Now, if you buy for the top max load, you might have happy customers, but for most of the year, you'll have idle resources, which means your average utilization is very low. And I've seen data centers with average utilization under 10% just out of fear of missing peak demand. So how do you solve the problem on premises? Well, the truth is, you can't. And here's where AWS changes the conversation entirely. What if you could provision your workload to exactly the demand, every hour, every day? Well, now you have happy customers, because they can always get the services they want. And you have a happy financial officer, because they get the ROI your company needs. And here's how it works. Morgan is behind the counter. She's taking orders. And we have a decoupled system. Morgan isn't doing all of the work here, so we need somebody making the drinks. Looks like Rudy's up. Now, the first problem I want to solve is the idea that we plan for a disaster. There's a great quote by Werner Vogel that says, everything fails all the time, so plan for failure and nothing fails. Or in other words, we ask ourselves, what would happen if we lost our order-taking instance? Well, we'd be out of business until we get another person to work the line. Another instance up and running. So here is where AWS makes it really simple. Using the same programmatic method we used to create the original Morgan, we can create a second Morgan. So if one fails, we have another one already on the front line and taking orders. The customers never lose service. Well, don't forget about the back end. Let's make our processing instances redundant as well. So that gets our regular operating capacity. We now have a highly available system with no single point of failure. And as long as the number of customers in line stays the same, we're good. But you know that's going to change, right? So let's take a look at what's going to happen when we have a rush of customers, an increase in demand. Now, there are two ways to handle growing demands. You can scale up or scale out. Scaling up means adding more power to the machines that are running, which might make sense in a few cases, but think about it. When you have an increase in customers, a bigger instance of Morgan really can't take a customer's order any faster, because that depends on the customer more than Morgan.
I'll take an espresso. Oh wait, is that organic? Make it a soy latte. Actually, I don't know. Do you just have tea?
What we need are, well, more Morgans. Customers? Oh no, looks like the processing instances are about to get overloaded, so let's scale them as well.
Obvious question is obvious. How come there are more order taker instances than order makers?
Well, in this case, the amount of work you can get done is still more than the order machines can send your way. You don't have a backlog, so no reason to add more worker instances. This is one of the great things about decoupling the system. You can end up with exactly the right amount of power for each part of your process, rather than over-provisioning to solve a separate problem. Okay, looks like we just cleared that rush. Now here's where AWS really makes a difference to your business. All these extra workers that are now sitting around idle, if you don't need them, send them home, or stop the instances. Amazon EC2 autoscaling adds instances based on demand, and then decommissions instances when they are no longer needed. This means that every minute of the day, you always have the correct number of instances. Happy customers, happy CFO, happy architecture. So we solved the scaling problem with Amazon EC2 autoscaling. But now we've got a bit of a traffic problem, don't we? Let's take a look at the situation. When customers come into the coffee shop, right now they have 3 options for which cashier to talk to place an order, and oddly enough, most of them are lining up in one line, causing an uneven distribution of customers per line, even though we have other cashiers waiting to take orders, standing around doing nothing. Customers come in and aren't sure exactly where to route their order. It would help a lot if we added a host in the situation. A host stands at the door, and when customers come into the coffee shop, they tell them which line to proceed to for placing their order. The host keeps an eye on the cashiers taking orders and counts the number of people in line each cashier is serving. Then it will direct new customers to the cashier that has the shortest line, is the least bogged down, thus allowing the lines to be even across cashiers and helping customers be served in the most efficient manner possible. The same idea applies to your AWS environment. When you have multiple EC2 instances all running the same program to serve the same purpose, and a request comes in, how does that request know which EC2 instance to go to? How can you ensure there's an even distribution of workload across EC2 instances, so not just one is backed up while the others are idle, sitting by? You need a way to route requests to instances to process that request. What you need to solve this is called load balancing. A load balancer is an application that takes in requests and routes them to the instances to be processed. Now, there are many off-the-shelf load balancers that work great on AWS. And if you have a favorite flavor that already does exactly what you want, then feel free to keep using it. In which case, it will be up to your operations team to install, manage, update, scale, handle failover, and availability. It's doable. Odds are what you really need is just to properly distribute traffic in a high-performance, cost-efficient, highly available, automatically scalable system that you can just set and forget. Introducing Elastic Load Balancing. Elastic Load Balancing, or ELB, is one of the first major managed services we're going to talk about in this course, and it's engineered to address the undifferentiated heavy lifting of load balancing. To illustrate this point, I need to zoom out a bit here. But to begin with, Elastic Load Balancing is a regional construct. And we'll explain more what that means in later videos, but the key value for you is that because it runs at the region level, rather than on individual EC2 instances, the service is automatically highly available with no additional effort on your part. ELB is automatically scalable. As your traffic grows, ELB is designed to handle the additional throughput with no change to the hourly cost. When your EC2 fleet autoscales out, as each instance comes online, the autoscaling service just lets the Elastic Load Balancing service know that it's ready to handle traffic, and off it goes. Once the fleet scales in, ELB first stops all new traffic and waits for the existing requests to complete, to drain out. Once they do that, then the autoscaling engine can terminate the instances without disruption to existing customers. ELB is not only used for external traffic. Let's look at the ordering tier and how it communicates with the production tier. Right now, each front-end instance is aware of each back-end instance. And if a new back-end instance comes online in this current architecture, it would have to tell every front-end instance that it can now accept traffic. This is complicated enough with just half a dozen instances. Now imagine you have potentially hundreds of instances on both tiers, each tier shifting constantly based on demand. Just keeping them networked efficiently is impossible. Well, we solve the back-end traffic chaos with an ELB as well. Because ELB is regional, it's a single URL that each front-end instance uses. Then the ELB directs traffic to the back-end that has the least outstanding requests. Now, if the back-end scales, once the new instance is ready, it just tells ELB that it can take traffic and it gets to work. The front-end doesn't know and doesn't care how many back-end instances are running. This is true decoupled architecture. There's even more that the ELB can do that we'll learn about later, but this is good enough for now. The key is choosing the right tool for the right job, which is one of the reasons AWS offers so many different services. For example, back-end communication. There are many ways to handle it, and ELB is just one method. Next, we'll talk about some other services that might work even better for some architectures.
Let's talk about messaging and queuing. In the coffee shop, there are cashiers taking orders from the customers and baristas making the orders. Currently, the cashier takes the order, writes it down with a pen and paper, and delivers this order to the barista. The barista then takes the paper and makes the order. When the next order comes in, the process repeats. This works great as long as both the cashier and the barista are in sync. But what would happen if the cashier took the order and turned to pass it to the barista, and the barista was out on break or busy with another order? Well, that cashier is stuck until the barista is ready to take the order, and at a certain point, the order will probably be dropped so the cashier can go serve the next customer. You can see how this is a flawed process, because as soon as either the cashier or barista is out of sync, the process will degrade, causing slowdowns in receiving orders and failures to complete orders at all. A much better process would be to introduce some sort of buffer or queue into the system. Instead of handing the order directly to the barista, the cashier would post the order to some sort of buffer, like an order board. This idea of placing messages into a buffer is called messaging and queuing. Just as our cashier sends orders to the barista, applications send messages to each other to communicate. If applications communicate directly, like our cashier and barista previously, this is called being tightly coupled. A hallmark trait of a tightly coupled architecture is where if a single component fails or changes, messages are sent in be available. Think of messages as our coffee orders and the order board as an SQS queue. Messages have the person's name, coffee order, and time they ordered. The data contained within a message is called a payload, and it's protected until delivery. SQS queues are where messages are placed until they are processed, and AWS manages the underlying infrastructure for you to host those queues. These scale automatically, are reliable, and are easy to configure and use. Now, Amazon SNS is similar in that it is used to send out messages to services, but it can also send out notifications to end users. It does this in a different way, called a publish-subscribe or pub-sub model. This means that you can create something called an SNS topic, which is just a channel for messages to be delivered. You then configure subscribers to that topic and finally publish messages for those subscribers. In practice, that means you can send one message to a topic, which will then fan out to all the subscribers in a single go. These subscribers can also be endpoints, such as SQS queues, AWS Lambda functions, and HTTPS or HTTP webhooks. Additionally, SNS can be used to fan out notifications to end users using mobile push, SMS, and email. Taking this back to our coffee shop, we could send out a notification when a customer's order is ready. This could be a simple SMS to let them know to pick it up, or even a mobile push. Oh, in fact, it looks like my phone just received a message. Looks like my order is ready. See you soon.
EC2 instances are virtual machines that you can provision with minimal friction to get up and running on AWS. And EC2 is great for all sorts of different use cases, like running basic web servers to running high-performance computing clusters and everything in between. That being said, though EC2 is incredibly flexible, reliable, and scalable, depending on your use case, you might be looking at alternatives for your compute capacity. EC2 requires that you set up and manage your fleet of instances. When you're using EC2, you are responsible for patching your instances when new software packages come out, setting up the scaling of those instances, as well as ensuring that you've architected your solutions to be hosted in a highly available manner. This is still not as much management as you would have if you hosted these on premises, but management processes will still need to be in place. You might be wondering, what other services does AWS offer for compute that are more convenient from a management perspective? This is where the term serverless comes in. AWS offers multiple serverless compute options. Serverless means that you cannot actually see or access the underlying infrastructure or instances that are hosting your application. Instead, all the management of the underlying environment from a provisioning, scaling, high availability, and maintenance perspective are taken care of for you. All you need to do is focus on your application, and the rest is taken care of. AWS Lambda is one serverless compute option. Lambda is a service that allows you to upload your code into what's called a Lambda function, configure your trigger, and from there, the service waits for the trigger. When the trigger is detected, the code is automatically run in a managed environment, an environment you do not need to worry too much about because it is automatically scalable, highly available, and all the maintenance of the environment itself is done by AWS. If you have 1 or 1,000 incoming triggers, Lambda will scale your function to meet demand. Lambda is designed to run code under 15 minutes, so this isn't for long-running processes like deep learning. It's more suited for quick processing, like a web backend handling requests, or a backend expense report processing service where each invocation takes less than 15 minutes to complete. If you aren't quite ready for serverless yet, or you need access to the underlying environment but still want efficiency and portability, you should look at AWS container services, like Amazon Elastic Container Service, otherwise known as ECS, or Amazon Elastic Kubernetes Service, otherwise known as EKS. Both of these services are container orchestration tools. But before I get too far here, a container, in this case, is a Docker container. Docker is a widely used platform that uses operating system level virtualization to deliver software in containers. Now, a container is a package system like Linux or Windows. You are going to want to use EC2. If you are looking to host short-running functions, service-oriented, or event-driven applications, and you don't want to manage the underlying environment at all, look into the serverless AWS Lambda. If you are looking to run Docker container-based workloads on AWS, you first need to choose your orchestration tool. Do you want to use Amazon ECS or Amazon EKS? After you choose your tool, you then need to choose your platform. Do you want to run your containers on EC2 instances that you manage, or in a serverless environment like AWS Fargate that is managed for you? Those are just some of your compute options with AWS, and it's not even a complete list. Check out the notes for more information on AWS compute services, as well as others that we didn't get to talk about in this video. Hey everyone, I hope you've been enjoying the course so far. We're going to do check-ins like this one after each major topic to review what you've learned. First things first, what is cloud computing and what does AWS offer? We define cloud computing as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. This means that you can make requests for IT resources like compute, networking, storage, analytics, or other types of resources, and then they're made available for you on demand. You don't pay for the resource upfront. Instead, you just provision and pay at the end of the month. AWS offers services in many categories that you use together to create your solutions. We've only covered a few services so far. You learned about Amazon EC2. With EC2, you can dynamically spin up and spin down virtual servers called EC2 instances. When you launch an EC2 instance, you choose the instance family. The instance family determines the hardware the instance runs on, and you can have instances that are built for your specific purpose. The categories are general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. You can scale your EC2 instances either vertically by resizing the instance or horizontally by launching new instances and adding them to the pool. You can set up automated horizontal scaling using Amazon EC2 autoscaling. Once you've scaled your EC2 instances out horizontally, you need something to distribute the incoming traffic across those instances. This is where the elastic load balancer comes into play. EC2 instances have different pricing models. There is on-demand, which is the most flexible and has no contract. Spot pricing, which allows you to utilize unused capacity at a discounted rate. Savings plans or reserved instances, which allow you to enter into a contract with AWS to get a discounted rate when you commit to a certain level of usage. And savings plans, which apply to AWS Lambda and AWS Fargate, as well as EC2 instances. We also covered messaging services. There is Amazon Simple Queue Service, or SQS. This service allows you to decouple system components. Messages remain in the queue until they are either consumed or deleted. Amazon Simple Notification Service, or SNS, is used for sending messages like emails, text messages, push notifications, or even HTTP requests. Once a message is published, it is sent to all of these subscribers. You also learned that AWS has different types of compute services beyond just virtual servers like EC2. There are container services like Amazon Elastic Container Service, or ECS. And there's Amazon Elastic Kubernetes Service, or EKS, both of which are container orchestration tools. You can use these tools with EC2 instances, but if you don't want to manage that, you don't need to. You can use AWS Fargate, which allows you to run your containers on top of a serverless compute platform. Then there is AWS Lambda, which allows you to just upload your code and configure to run based on triggers. And you only get charged for when the code is actually running. No containers, no virtual machines. Just code and configuration. Hopefully that sums it up. Catch you in the next one. Say you want to grab a cup of coffee at the cafe, but today is not just a normal day in our city. Today, there is a parade coming to march down our street in celebration of all of the wonderful cloud migrations that have been successful. This parade is going to march right in front of our shop. This is great because who doesn't love to look at floats and balloons and have someone throw candy at them from the street? But this is also bad because while the parade is coming down the street, our customers who are driving to come get coffee will be diverted and won't be able to stop by the shop. This will drive sales down and also make customers unhappy. Luckily for us, we thought ahead. We thought long ago, what would happen if for some reason our customers couldn't make it into the shop temporarily? Like if there was a parade, or if there was a flood, or some other event that blocks us from getting into the shop. Well, no matter the reason, we need to be highly available for our customers. So, I'll let you in on a secret. This isn't our coffee shop's only location. The cafe is actually a chain, and we have locations all around the city. That way, if a parade comes down the street or if there was a power outage on our block, no worries. Customers can still get their coffee by visiting one of our shops just a few blocks away. We still make money and they get their coffee, all is well. AWS has done a similar thing with how the AWS global infrastructure is set up. It's not good enough to have one giant data center where all of the resources are. If something were to happen to that data center, like a power outage or a natural disaster, everyone's applications would go down all at once. You need high availability and fault tolerance. Turns out it's not even good enough to have two giant data centers. Instead, AWS operates in all sorts of different areas around the world called regions. We're going to talk about this in depth in upcoming videos. In the meantime, I'm going to sit here and relax because I know my business is highly available, regardless of any parades blocking the street.
To understand the global infrastructure AWS, I want to begin with your fundamental business needs. You have an application that you have to run, or content you need stored, or data you need analyzed. Basically, you have stuff that has to live and operate somewhere. Now, historically, businesses had to run applications in their own data centers because they didn't have a choice. Once AWS became available, companies like yours could now run their applications in other data centers they didn't actually own. But the conversation is so much more than that. Because I want you to understand a fundamental problem with any data center. It doesn't matter who built it or who owns it. Events can happen that could cause you to lose connection to that building. If you run your own data center, you have to do each other region through a high-speed fiber network controlled by AWS, a truly global operation from corner to corner if you need it to be. Now, before we get into the architecture of how each region is built, it's important to know that you, the business decision maker, gets to choose which region you want to run out of. And each region is isolated from every other region, in the sense that absolutely no data goes in or out of your environment in that region without you explicitly granting permission for that data to be moved. This is a critical security conversation to have. For example, you might have government compliance requirements that your financial information in Frankfurt cannot leave Germany. Well, this is absolutely the way AWS operates out of the box. Any data stored in the Frankfurt region never leaves the Frankfurt region, or data in the London region never leaves London, or Sydney never leaves Sydney, unless you explicitly, with the right credentials and permissions, request the data be exported. Regional data sovereignty is part of the critical design of AWS regions, with data being subject to the local laws and statutes of the country where the region lives. So with that understanding that your data, your application, lives and runs in a region, one of the first decisions you get to make is which region do you pick? There's 4 business factors that go into choosing a region. Number 1, compliance. Before any of the other factors, you must first look at your compliance requirements. Do you have a requirement? Your data must live in UK boundaries? Then you should choose the London region. Full stop. I mean, none of the rest of the options matter. Or let's say you must run inside Chinese borders. Well, then you should choose one of our Chinese regions. Most businesses, though, are not governed by such strict regulations. So if you don't have a compliance or regulatory control that dictates your region, then you can look at the other factors. Number 2, proximity. How close you are to your customer base is a major factor because speed of light is still a law of the universe. If most of your customers live in Singapore, consider running out of the Singapore region. You certainly can run out of Virginia, but the time it takes for the information to be sent, or latency, between the US and Singapore is always going to be a factor. Now, we may be developing quantum computing, but quantum networking, still some ways away. The time it takes light to travel around the world is always a consideration. Locating close to your customer base, usually the right call. Number 3, feature availability. Sometimes the closest region may not have all the AWS features you want. Now, here's one of the cool things about AWS. We are constantly innovating on behalf of our customers. Every year, AWS releases thousands of new features and products specifically to answer customer requests and needs. But sometimes those brand new services take a lot of new physical hardware that AWS has to build out to make the service operational. And sometimes that means we have to build the service out one region at a time. So let's say your developers wanted to play with Amazon Bracket, our new quantum computing platform. Well, then they have to run in the regions that already have the hardware installed. Eventually, can we expect it to be in every region? Well, yeah, that's a good expectation. But if you want to use it today, then that might be your deciding factor. Number 4, pricing. Even when the hardware is equal one region to the next, some locations are just more expensive to operate in. For example, Brazil. Now, Brazil's tax structure is such that it costs AWS significantly more to operate the exact same services there than in many other countries. The exact same workload in Sao Paulo might be, let's say, 50% more expensive to run than out of Oregon in the United States. Price can be determined by many factors, so AWS has very transparent, granular pricing that we'll continue to discuss in this class. But know that each region has a different price sheet. So if budget is your primary concern, even if your customers live in Brazil, you might still want to operate in a different country, again, if price is your primary motivation. So 4 key factors to choose a region: compliance, proximity, feature availability, and pricing. When we come back, we'll look at the moving parts inside a region.
If a region is where all of the pieces and parts of your application live, some of you might be thinking that we never actually solved the problem that we presented in the last video. Let me restate the problem. You don't want to run your application in a single building because a single building can fail for any number of unavoidable reasons. You may be thinking, if my business needs to be disaster-proof, then it can't run in just one location. Well, you're absolutely correct. AWS agrees with that statement, and that's why our regions are not one location. To begin with, AWS has data centers, lots of data centers, all around the world, and each region is made up of multiple data centers. AWS calls a single data center, or a group of data centers, an availability zone, or AZ. Each availability zone is one or more discrete data centers, far apart as you can, before the speed of light. This is actually a regional construct. It runs across all availability zones, communicating with the EC2 instances that are running in a specific availability zone. Regional services are by definition already highly available, at no additional cost of effort on your part. So as you plan for high availability, any service that is listed as a regionally scoped service, you already have that box checked. When we come back, let's look at going outside the regions for additional solutions.
One of the great things about the AWS global infrastructure is the way it's engineered to help you better serve your customers. Remember, when selecting a region, one of the major criteria was proximity to your customers. But what if you have customers all over the world, or in cities that are not close to one of our regions? Well, think about our coffee shop. If you have a good customer base in a new city, you can build a satellite store to service those customers. You don't need to build an entire new headquarters. Or from an IT perspective, if you have customers in Mumbai who need access to your data, but the data is hosted out of the Tokyo region, rather than having all the Mumbai-based customers send requests all the way to Tokyo to access the data, just place a copy locally, or cache a copy in Mumbai. Caching copies of data closer to customers all around the world uses the concept of content delivery networks, or CDNs. And CDNs are commonly used, and at AWS, we call our CDN Amazon CloudFront. Amazon CloudFront is a service that helps deliver data, video, applications, and APIs to customers around the world with low latency and high transfer speeds. Amazon CloudFront uses what are called edge locations all around the world to help accelerate communication with users no matter where they are. Edge locations are separate from regions, so you can push content from inside a region to a collection of edge locations around the world in order to accelerate communication and content delivery. AWS Edge locations also run more than just CloudFront. They run a domain name service, or DNS, known as Amazon Route 53, helping direct customers to the correct web locations with reliably low latency. But what if your business wants to use AWS services inside their own building? Well, sure, AWS can do that for you. Introducing AWS Outposts, where AWS will basically install a fully operational mini region right inside your own data center. That's owned and operated by AWS, using 100% of AWS functionality, but isolated within your own building. It's not a solution most customers need, but if you have specific problems that can only be solved by staying in your own building, well, we understand. AWS Outposts can help. All right, there is so much more that we can say about our AWS global infrastructure, but let's keep it simple and stop here. So here's the key points. Number one, regions are geographically isolated areas where you can access services needed to run your enterprise. Number two, regions contain availability zones that allow you to run across physically separated buildings, tens of miles of separation, while keeping your application logically unified. Availability zones help you solve high availability and disaster recovery scenarios without any additional effort on your part. And number three, AWS Edge locations run Amazon CloudFront to help get content closer to your customers no matter where they are in the world.
We've been talking about a few different AWS resources as well as the AWS global infrastructure. You may be wondering, how do I actually interact with these services? And the answer is APIs. In AWS, everything is an API call. An API is an application programming interface. And what that means is there are predetermined ways for you to interact with AWS services. And you can invoke or call these APIs to provision, configure, and manage your AWS resources. For example, you can launch an EC2 instance, or you can create an AWS Lambda function. Each of those would be different requests and different API calls to AWS. You can use the AWS Management Console, the AWS Command Line Interface, the AWS Software Development Kits, or various other tools like AWS CloudFormation to create requests to send to AWS APIs to create and manage AWS resources. First, let's talk about the AWS Management Console. The AWS Management Console is browser-based. Through the console, you can manage your AWS resources visually and in a way that is easy to digest. This is great for getting started and building your knowledge of the services. It's also useful for building out test environments or viewing AWS bills, viewing monitoring, and working with other non-technical resources. The AWS Management Console is most likely the first place you will go when you are learning about AWS. However, once you are up and running in a production type environment, you don't want to rely on the point-and-click style that the console gives you to create and manage your AWS resources. For example, in order to create an Amazon EC2 instance, you need to click through various screens, setting all the configurations you want, and then you launch your instance. If later you wanted to launch another EC2 instance, you would need to go back into the console and click through those screens again to get it up and running. By having humans do this sort of manual provisioning, you are opening yourself up to potential errors. It's pretty easy to forget to check a checkbox or misspell something when you are doing everything manually. The answer to this problem is to use tools that allow you to script or program the API calls. One tool you can use is the AWS Command Line Interface, or CLI. The CLI allows you to make API calls using the terminal on your machine. This is different than the visual navigation style of the management console. This makes it easy for developers to create programs that use AWS without using the low-level APIs, as well as avoiding that manual resource creation that we just talked about. More on that in a bit. All right, let's continue to talk about how to interact with AWS. You have the AWS Management Console, the CLI, and the SDKs, which are all sort of do-it-yourself ways to provision and manage your AWS environment. If you want to provision a resource, you can log into the console and point and click. You can write some commands, or you can write some programs to do it. There are also other ways you can manage your AWS environment using managed tools like AWS Elastic Beanstalk and AWS CloudFormation. AWS Elastic Beanstalk is a service that helps you provision Amazon EC2-based environments. Instead of clicking around the console or writing multiple commands to build out your network, EC2 instances, scaling, and Elastic load balancers, you can instead provide your application code and desired configurations to the AWS Elastic Beanstalk service, which then takes that information and builds out your environment for you. AWS Elastic Beanstalk also makes it easy to save environment configurations, so they can be deployed again easily. AWS Elastic Beanstalk gives you the convenience of not having to provision and manage all of these pieces separately, while still giving you the visibility and control of the underlying resources. You get to focus on your business application, not the infrastructure. Another service you can use to help create automated and repeatable deployments is AWS CloudFormation. AWS CloudFormation is an infrastructure as code tool that allows you to define a wide variety. The AWS Management Console is a manual tool, so right off the bat, it isn't a great option for automation. You can instead use the CLI to script your interactions with AWS using the terminal. You can use the SDKs to write programs to interact with AWS for you, or you can use managed tools like AWS Elastic.
Awesome stuff. I mean, we covered a lot of ground in here. And I don't mean that just because we talked about AWS global infrastructure. But seriously, we covered how logical clusters of data centers make up availability zones. Availability zones in turn make up regions, and those are spread globally. You then choose what regions and availability zones you want to operate out of. And as a best practice, you should always deploy infrastructure across at least 2 availability zones. And some AWS services like Elastic Load Balancing, Amazon SQS, and Amazon SNS already do this for you. We also talked about edge locations and how you can deploy content there to speed up delivery to your customers. We even touched upon edge devices like AWS Outposts, which allow you to run AWS infrastructure right in your own data center. Another thing we discussed was how to provision AWS resources through various options, such as the AWS Management Console, the SDK, CLI, AWS Elastic Beanstalk, and AWS CloudFormation, where you learn how you can set up your infrastructure as code. I hope you learn how globally available AWS is and how easy it is to get started with provisioning resources. If we think back to our coffee shop or AWS account, things by now should be running smoothly. Although, what if we had a few eager customers who wanted to give their orders directly to the baristas instead of the cashier out in front? Well, it doesn't make sense to allow every customer to be able to interact with our baristas since they are focused on brewing some fresh caffeinated beverages. So what do? That's right, kids, stay with me. Amazon Virtual Private Cloud, or VPCs as they're affectionately known. A VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. These resources can be public-facing, so they have access to the internet, or private, with no internet access, usually for backend services like databases or application servers. The public and private grouping of resources are known as subnets, and there are ranges of IP addresses in your VPC. Now, in our coffee shop, we have different employees, and one is a cashier. They take customers' orders, and thus we want customers to interact with them, so we put them in what we call a public subnet. Hence, they can talk to the customers or the internet. But for our baristas, we want them to focus on making coffee and not interact with customers directly, so we put them in a private subnet. Okay, let's get into the next video, where we'll dive into networking.
A VPC, or virtual private cloud, is essentially your own private network in AWS. A VPC allows you to define your private IP range for your AWS resources, and you place things like EC2 instances and ELBs inside of your VPC. Now, you don't just go throw your resources into a VPC and move on. You place them into different subnets. Subnets are chunks of IP addresses in your VPC that allow you to group resources together. Subnets, along with networking rules we will cover later, control whether resources are either publicly or privately available. What we haven't told you yet is there are actually ways you can control what traffic gets into your VPC at all. What I mean by this is, for some VPCs, you might have internet-facing resources that the public should be able to reach, like a public website, for example. However, in other scenarios, you might have resources that you only want to be reachable if someone is logged into your private network. This might be internal services like an HR application or a backend database. First, let's talk about public-facing resources. In order to allow traffic from the public internet to flow into and out of your VPC, you must attach what is called an internet gateway, or IGW, to your VPC. An internet gateway is like a doorway that is open to the public. Think of our coffee shop. Without a front door, the customers couldn't get in and order their coffee. So we install a front door, and the people can then go in and out of that door when coming and going from our shop. The front door in this example is like an internet gateway. Without it, no one can reach the resources placed inside of your VPC. Next, let's talk about a VPC with all internal private into the coffee shop. No one else driving around on the road can slow me down, because this is my direct doorway. No one else can use it. What, did you not have a secret magic doorway into your favorite coffee shop? All right, moving on. The point being is you still want a private connection, but you want it to be dedicated and shared with no one else. You want the lowest amount of latency possible with the highest amount of security possible. With AWS, you can achieve that using what is called AWS Direct Connect. Direct Connect allows you to establish a completely private, dedicated fiber connection from your data center to AWS. You work with a Direct Connect partner in your area to establish this connection, because like my magic doorway, AWS Direct Connect provides a physical line that connects your network to your AWS VPC. This can help you meet high regulatory and compliance needs, as well as sidestep any potential bandwidth issues. It's also important to note that one VPC might have multiple types of gateways attached for multiple types of resources, all residing in the same VPC, just in different subnets. Thanks for listening. I'm going to sit here and keep ordering coffees from my magic door. See ya.
Welcome to your VPC. You can think of it as a hardened fortress where nothing goes in or out without explicit permission. You have a gateway on the VPC that only permits traffic in or out of the VPC. But that only covers perimeter, and that's only one part of network security that you should be focusing on as part of your IT strategy. AWS has a wide range of tools that cover every layer of security: network hardening, application security, user identity, authentication and authorization, distributed denial of service, leave or enter the subnet based on access questions. We introduce doorman and leave. Cool. Right, the packet made it past the security group of instance A has to be on your approved list to make it across the border. Security group recognizes the packet from before, so it doesn't need to check to see if it's allowed. Well, then you need to sign up for a completely
We've been talking a lot about how you interact with your AWS infrastructure, but how do your customers interact with your AWS infrastructure? Well, if you have a website hosted in AWS, then customers usually enter your website into their browser, hit enter, some magic happens, and the site opens up. But how does this magic work? Well, just like this magic coin that I have here. You take a bite, and it's back. Well, not quite like that, but I'm going to take you through two services which would help in the website case. The first one being Route 53. Route 53 is AWS's domain name service, or DNS, and it's highly available and scalable. But wait, what is DNS, you say? Think of DNS as a translation service, but instead of translating between languages, it translates website names into IP or Internet Protocol addresses that computers can read. For example, when we enter a website address into our browser, it contacts Route 53 to obtain the IP address of the site, say 192.1.1.1. Then it routes your computer or browser to that address. If we go further, Route 53 can direct traffic to different endpoints using several different routing policies, such as latency-based routing, geolocation DNS, geoproximity, and weighted round robin. If we take geolocation DNS, that means we direct traffic based on where the customer is located. So traffic coming from, say, North America is routed to the Oregon region, and traffic in Ireland is routed to the Dublin region, as an example. You can even use Route 53 to register domain names, so you can buy and manage your own domain names right on AWS. Speaking of websites, there's another service which can help speed up delivery of website assets to customers, Amazon CloudFront. If you remember, we talked about edge locations earlier in the course. These locations are serving content as close to customers as possible, and one part of that is the Content Delivery Network, or CDN. For those who need reminding, a CDN is a network that helps to deliver edge content to users based on their geographic location. If we go back to our North America versus Ireland example, say we have a user in Seattle and they want to access a website. To speed this up, we host the site in Oregon and we deploy our static web assets like images and GIFs in CloudFront in North America. This means they get content delivered as close to them as possible, North America in this case, when they access the site. But for our Irish users, it doesn't make sense to deliver those assets out of Oregon as the latency is not favorable. Thus, we deploy those same static assets in CloudFront, but this time in the Dublin region. That means they can access the same content, but from a location closer to them, which in turn improves latency. I hope you're content after learning about these two services. Thanks for following along, and I'm going to disappear just like this red cloth. Ta-da!
Networking used to be the exclusive domain of topological geniuses. But AWS, networking is now simplified and abstracted to answer the simple question of who should be allowed to communicate with each other. As long as you can answer that question, then you can set up your network on AWS. We covered the basics of VPC, the virtual private cloud, the way that you isolate your workload in AWS, the fundamentals of network security, including gateways, network ACLs, and security groups. All methods that allow your security engineers to craft a network that allows healthy traffic access while dropping subversive attacks before they reach your instance. Ways to connect to AWS through VPN and even direct connect, secure pipelines that are either encrypted over the general internet or exclusive fiber used by you and you alone. We also talked about the global networks AWS provides using our edge locations, how you can use Route 53 for DNS, and how to use CloudFront to cache content closer to your actual consumers. So while this only scratches the surface of the many things you can do with AWS networking, we hope that it gives you an understanding of the key moving pieces you need to get your business started. Well, we have quite a coffee operation going now. We've got customers, lots of happy customers. In fact, we have an elastic, scalable, disaster-resistant, cost-optimized architecture that now has a global, highly secured network that can be deployed entirely programmatically. You know, now we need some way to show our appreciation to all our loyal customers. How about a frequent drinker loyalty program? We could just hand out punch cards, but let's be honest, we can't track those well and use them to get to know our customers better. We need digital cards, which means we need to be able to keep track of our customers, what they order, how much they purchased. This will help them, the customers, get the best rewards they've earned and help us to know our customer base better. This means we need databases. Databases and storage. And not just any database, we need to make sure we choose the right database for the task and the right storage for the data types. Now, you may have many different data usage needs and data types. Let's learn about the different services AWS has to help you build the perfect data solution.
When you're using Amazon EC2 to run your business applications, those applications need access to CPU, memory, network, and storage. EC2 instances give you access to all those different components, and right now, let's focus on the storage access. As applications run, they will oftentimes need access to block-level storage. You can think of block-level storage as a place to store files, a file being a series of bytes that are stored in blocks on disk. When a file is updated, the whole series of blocks aren't all overwritten. Instead, it updates just the pieces that change. This makes it an efficient storage type when working with applications like databases, enterprise software, or file systems. When you use your laptop or personal computer, you are accessing block-level storage. All block-level storage is, in this case, is your hard drive. EC2 instances have hard drives as well, and there are a few different types. When you launch an EC2 instance, depending on the type of the EC2 instance you launched, it might provide you with local storage called instance store volumes. These volumes are physically attached to the host your EC2 instance is running on top of, and you can write to it just like a normal hard drive. The catch here is that since this volume is attached to the underlying physical host, if you stop or terminate your EC2 instance, all data written to the instance store volume will be deleted. Amazon Elastic Block Store, or EBS, comes into play. With EBS, you can create virtual hard drives that we call EBS volumes that you can attach to your EC2 instances. These are separate drives from the local instance store volumes, and they aren't tied directly to the host that your EC2 is running on. This means that the data that you write to an EBS volume can persist between stops and starts of an EC2 instance. EBS volumes come in all different sizes and types. How this works is you define the size, type, and configurations of the volume you need, provision the volume, and then attach it to your EC2 instance. Shots of your EBS volumes. This way, if a drive ever becomes corrupted,
Welcome to this video on Amazon Simple Storage Service, or S3. From the name, you've probably guessed that it is a storage service, and it's, well, simple. Most businesses have data that needs to be stored somewhere. For the coffee shop, this could be receipts, images, Excel spreadsheets, employee training videos, and even text files, among others. Storing these files is where S3 comes in handy, because it is a data store that allows you to store and retrieve an unlimited amount of data at any scale. Data is stored as objects, but instead of storing them in a file directory, you store them in what we call buckets. Think of a file sitting on your hard drive. That is an object, and think of a file directory. That is the bucket. The maximum object size that you can upload is 5 terabytes. You can also version objects to protect them from accidental deletion of an object. What this means is that you always retain the previous versions of an object as like a paper trail. You can even create multiple buckets and store them across different classes or tiers of data. You can then create permissions to limit who can see or even access objects, and you can even stage data between different tiers. These tiers offer mechanisms for different storage use cases, such as data that needs to be accessed frequently versus audit data that needs to be retained for several years. You can employ an S3 Glacier vault lock policy and lock your vault. You can specify controls such as write once, read many, or worm in a vault lock policy and lock the policy from future edits. Once locked, the policy can no longer be changed. You also have 3 options for retrieval, which range from minutes to hours, and you have the option of uploading directly to Glacier or using S3 lifecycle policies. In fact, I don't think we mentioned lifecycle policies up till this point, but they are policies you can create that can move data automatically between tiers. For example, say we need to keep an object in S3 standard for 90 days, and then we want to move it to S3 IA for the next 30 days. Then, after 120 days total, we want it to be moved to S3 Glacier. With lifecycle policies, you create that configuration without changing your application code, and it will perform those moves for you automatically. It's another example of a managed AWS service helping take that burden off you so you can focus on more of your business needs. Just to note that there are other storage classes like S3 Infrequent Access One Zone and S3 Glacier Deep Archive that you can use. Happy storing.
Next up on the list of storage services is Amazon Elastic File System, or what we call EFS. EFS is a managed file system. It's extremely common for businesses to have shared file systems across their applications. For example, you might have multiple servers running analytics on large amounts of data being stored in a shared file system. This data traditionally has been hosted on-premises. In this on-premises data center, you would have to ensure that the storage you have can keep up with the amount of data that you are storing, make sure backups are taken, and that the data is stored redundantly, as well as manage all of the servers hosting that data. Luckily, with AWS, you don't need to worry about buying all of that hardware and keeping the whole file system running from an operational standpoint. With EFS, you can keep existing file systems in place, but files on it, you can also run a database on top of it or store applications on it. It's a hard drive. If you provision a 2 terabyte EBS volume and fill it up, it doesn't automatically scale to give you more storage. So that's EBS. Amazon EFS can have multiple instances reading and writing from it at the same time. But it isn't just a blank hard drive that you can write to. It is a true file system for Linux. It is also a regional resource, meaning any EC2 instance in the region can write to the EFS file system. As you write more data to EFS, it automatically scales. No need to provision any more volumes.
So you're storing data about your coffee shop in various systems, but you're finding that you need to maintain relationships between various types of data. And by relationships, I mean, if say a customer orders the same drink multiple times, maybe you want to offer them a promotional discount on their next purchase, and you need a way to keep track of this relationship somewhere. In this case, it's best to use a relational database management system, or RDBMS. Essentially, it means we store data in a way such that it relates to other pieces of data. For example, if we had a customer entry or record, we store that in a customer table. We then could have an entry for their physical address, which we store in a corresponding address table. We then relate the two via a common attribute and can query the data that is housed in both tables. The most common way to query the data is by writing queries in SQL. And this runs on a variety of database systems. Speaking of database systems, what are some of the more well-known ones that AWS supports? Well, there's MySQL, PostgreSQL, Oracle, Microsoft SQL Server, and many more. If you have an on-premises environment, you're probably running one of those, and they are most likely housed in your data center. But is there a way to easily move them to the cloud? Well, the simple answer is yes. You can do what we call a lift and shift and migrate your database to run on Amazon EC2. This means you have control over the same variables you do in your on-premises environment, such as OS, memory, CPU, storage capacity, and so forth. It's a quick entry to the cloud, and you can migrate them using standard practices or using something like Database Migration Service, which we'll cover in a later video. The other option for running your databases in the cloud is to use a more managed service called Amazon Relational Database Service, or RDS. It supports all the major database engines, like the ones we mentioned earlier, but this service comes with added benefits. These include automated patching, backups, redundancy, failover, disaster recovery, all of which you normally have to manage for yourself. This makes it an extremely attractive option to AWS customers, as it allows you to focus on business problems and not maintaining databases, which, if you're a database admin, can be pretty time-consuming and difficult. So how do we make it even easier for you to run database workloads on the cloud? Well, we go one further and have them migrate or deploy to Amazon Aurora. It's our most managed relational database option and comes in two forms, MySQL and Postgres, and is priced as 1/10 the cost of commercial-grade databases. That's a pretty cost-effective database. The other benefits are things like your data is replicated across facilities, so you have 6 copies at any given time. You can also deploy up to 15 read replicas, so you can offload your reads and scale performance. Additionally, there's continuous backups to S3, so you always have a backup ready to restore. You also get point-in-time recovery, so you can recover data from a specific period. And there you have it, relational databases in a nutshell.
Let's talk about Amazon DynamoDB. At its most basic level, DynamoDB is a database. It's a serverless database, meaning you don't need to manage the underlying instances or infrastructure powering it. With DynamoDB, you create tables. A DynamoDB is a non-relational database. Non-relational databases tend to have simple, flexible schemas, not complex, rigid schemas laying out multiple tables that all relate to each other. With DynamoDB, you can add and remove attributes from items in the table at any time. Not every item in the table has to have the same attributes. This is great for datasets that have some variation from item to item. Because of this flexibility, you cannot run complex SQL queries on it. Instead, you would write queries based on a small subset of attributes that are designated as keys. Because of this, the queries that you run on non-relational databases tend to be simpler and focus on a collection of items from one table, not queries that span multiple tables. This query pattern, along with other factors, including the way that the underlying system is designed, allows DynamoDB to be very quick in response time and highly scalable. So, things to remember. DynamoDB is a non-relational NoSQL database. It is purpose-built, meaning it has specific use cases and it isn't the best fit for every workload out there. It has millisecond response time, it's fully managed, and it's highly scalable. One awesome example is on Prime Day in 2019, across the 48 hours of Prime Day, there were 7.11 trillion calls to the DynamoDB API, peaking at 45.4 million requests per second. That's insanely scalable, all without the underlying database management. That's pretty cool.
We just spent a lot of time discussing the kinds of workflow that require fast, reliable, current data. Databases that can handle thousands of transactions per second, storage that is highly available and massively durable. But sometimes we have a business need that goes outside what is happening right now to what did happen. This data analysis is the realm of a whole different class of databases. Sure, you could use the one-size-fits-all model of a single database for everything, but modern databases that are engineered for high-speed, real-time ingestion and queries may not be the best fit. Let me explain. In order to handle the velocity of real-time read-write functionality, most relational databases tend to function fabulously at certain capacities, how much content it actually stores. The problem with historical analytics, data that answers questions like, show me how production has improved since we started, is the data collection never stops. In fact, with modern telemetry and the explosion of IoT, the volume of data will overwhelm even the beefiest traditional relational database. It gets worse. With Spectrum, you can directly run a single SQL query against exabytes of unstructured data running in data lakes. But it's more than just being able to handle massively larger data sets. Redshift uses a variety of innovations that allow you to achieve up to 10 times higher performance than traditional databases when it comes to these kind of business intelligence workloads. I'm not going to go into details of how the magic works. We have whole classes that you or your data teams can take that explain how it is built and why it can return such improved results. The key for you is to understand that when you need big data BI solutions, Redshift allows you to get started with a single API call. Less time waiting for results, more time getting answers.
We've been talking about databases and the various database options on AWS, but what happens if you have a database that's on-premises or in the cloud already? Does that mean you have to start from scratch, or does AWS have a magical way to help you migrate your existing database? Thankfully, AWS offers a service called Amazon Database Migration Service, or DMS, to help customers do just that. DMS helps customers migrate existing databases onto AWS in a secure and easy fashion. You essentially migrate data between a source and a target database. The best part is that the source database remains fully operational during the migration, minimizing downtime to applications that rely on that database. Better yet is that the source and target databases don't have to be of the same type. But let's start with databases that are of the same type. These migrations are known as homogeneous and can be from MySQL to Amazon RDS for MySQL, Microsoft SQL Server to Amazon RDS for SQL Server, or even Oracle to Amazon RDS for Oracle. The process is fairly straightforward since schema structures, data types, and database code is compatible between source and target. As I mentioned, the source database can be located on-premises, running on Amazon EC2 instances, or it can be an Amazon RDS database. The target itself can be a database in Amazon EC2 or Amazon RDS. In this case, you create a migration task with connections to the source and target databases. Then start the migration with a click of the button. AWS Database Migration Service takes care of the rest. The second type of migration occurs when source and target databases are of different types. This is called heterogeneous migrations, and it's a two-step process. Since the schema structures, data types, and database code are different between source and target, we first need to convert them using the AWS Schema Conversion tool. This will convert the source schema and code to match that of the target database. The next step is then to use DMS to migrate data from the source database to the target database. But these are not the only use cases for DMS. Others include development and test database migration, database consolidation, and even continuous database replication. Development and test migration is when you want your developers to test against production data, but without affecting production users. In this case, you use DMS to migrate a copy of your production database to your dev or test environments, either once-off or continuously. Database consolidation is when you have several databases and want to consolidate them into one central database. Finally, continuous replication is when you use DMS to perform continuous data replication. This could be for disaster recovery or because of geographic separation. If you'd like to learn more about any of these, please check out our resources section. And there you have it, folks. DMS in a nutshell.
Before we wrap up databases and storage, I want to loop back to the topic that we started all this with. Choosing the right database. Choosing the right storage platform to fit your business needs, rather than forcing your data to fit your database's requirements. No matter what a database vendor might try to tell you, there is no one-size-fits-all database for all purposes. We've covered quite a few database flavors already, but there are even more databases AWS offers for special business requirements that we don't have time to cover, but it's worth just knowing they're there in case you need them. For example, we talked about DynamoDB, and that's great for key-value pair databases. But what if you need more than just small attributes? What if you need a full content management system? Introducing Amazon Document DB. Great for content management, catalogs, user profiles. What if you had a social network that you wanted to track? Well, those kind of social webs, who is connected to who, is very clunky to manage in a traditional relational database. So, Amazon Neptune, a graph database, engineered for social networking and recommendation engines. Also great for fraud detection needs. Or perhaps you have a supply chain. Starting with adding caching layers on top of your databases that can help improve the read times of common requests from milliseconds to microseconds. Amazon Elasticache can provide those caching layers without your data team needing to worry about the heavy lifting of launching, uplift, and maintenance. And it comes in both Memcached and Redis flavors. Or if you're using DynamoDB, try using DAX, the DynamoDB Accelerator, a native caching layer designed to dramatically improve read times for your non-relational data. The key thing to understand is AWS wants to make sure that you're using the best tool for the job.
Another module completed. Awesome stuff. You learned about all the different types of AWS storage mechanisms. Let's recap them, shall we? The first one we learned about is elastic block store volumes, and you attach those to EC2 instances, so you have local storage that is not ephemeral. You learned about how S3 and how you can store objects in AWS with the click of a button or call of an API. We even discussed the various relational database options available on AWS. Or for the workloads that just need a key value pair, we have the non-relational offering called DynamoDB. Next up was EFS for file storage use cases. We then have Amazon Redshift for all our data warehouse needs. And to aid in migration of existing databases, we have DMS or Database Migration Service. We also touched upon the lesser known storage services like DocumentDB, Neptune, QLDB, and Amazon Managed Blockchain. Lastly, we talked about how caching solutions like Elasticache and DynamoDB Accelerator can be used. That's a lot of places to store different types of data, and hopefully you've learned the correct place to store each type. Looks like we're getting deeper into our AWS account. Things are running well, and I want to let you in on the security measures we have in place. By this, I mean we have to describe the various security mechanisms we offer on the AWS cloud, like the shared responsibility model. With the shared responsibility model, AWS controls security of the cloud, and customers control security in the cloud. We, as AWS, control the data centers, security of our services, and all the layers in this section. The next part are the workloads that AWS customers run in the cloud, and those are the customer's responsibility to secure. It's something we share with customers to ensure security in the cloud. Let's take a look at the various other security services, mechanisms, and features that
When it comes to securing your business on AWS, it's important to ask the question, who is ultimately responsible for the security? Is it A, you the customer, or B, AWS? And the correct answer is yes. Both. Both are ultimately responsible for making sure that you are secure. Now, if there's any security experts watching this right now, you're probably shaking your head saying you can't have two different entities with the ultimate responsibility over a single object. That's not security, that's wishful thinking. At AWS, we agree completely. But for us, we don't look at your environment as a single object. Instead, we see it as a collection of parts that build on each other. AWS is responsible for the security of some of the objects, responsible 100% for those. The others, you are responsible 100% for their security. This is what's known as the shared responsibility model. It's a encryption key to log on to the root of this OS or to create any user accounts there. No more than a construction company would keep copies of your front door key, AWS cannot enter your operating system. And here's a hint. If someone from AWS calls and asks you for your OS key, it is not AWS. Now that means your operations team is 100% responsible for keeping the operating system patched. If AWS discovers there are some new vulnerabilities in your version of Windows, let's say, we can certainly notify your account owner, but we cannot deploy a patch. This is a really good thing for your security. This means no one can deploy anything that might break your system without your team being the ones that do it. Now, on top of that OS, you can run whatever applications you want. You own them. Door open, all anyone would see is unreadable encrypted content. The AWS shared responsibility model is about making sure both sides understand exactly what tasks are ours. Basically, AWS is responsible for the security of the cloud, and you are responsible for the security in the cloud. Together, you have an environment you can trust.
In the coffee shop, every employee has an identity. They come into work in the morning and they log in. It is so powerful, we recommend that as soon as you create an AWS account and log in, for example, you can see we have a permission statement. And you also have policies, which are documents that describe permissions that you can then attach to your name and password. Instead, it is an identity that you can assume to gain access to temporary permissions. You use roles to temporarily grant access to AWS resources to users, external identities, applications, and even other AWS services. When an identity assumes a role, it abandons all of the previous permissions that it has, and it assumes the permissions of that role. You can actually avoid creating IAM users for every person in your organization by federating users into your account.
With your first foray into the AWS cloud, you most likely will start with one AWS account and have everything reside in there. Most people start this way, but as your company grows or even begins their cloud journey, it's important to have a separation of duties. For example, you want your developers to have access to development resources, have your accounting staff able to access billing information, or even have business units separate so that they can experiment with AWS services we had, A, B, C, F, G. Now you can put those accounts into one OU. Or if you have accounts that fall to to specify the maximum permissions for member accounts in the organization. In essence, with SCPs, you can restrict which AWS services, resources, and individual API actions the users and roles in each member account can access.
For every industry, there are specific standards that need to be upheld, and you will be audited or inspected to ensure that you have met those standards. For example, for a coffee shop, the health inspector will come by and check that everything is up to code and sanitary. Similarly, you could be audited for taxes to see that you have run the back office correctly and have followed the law. You rely on documentation, records, and inspections to pass audits and compliance checks as they come along. You'll need to devise a similar way to meet compliance and auditing in AWS. Depending on what types of solutions you host on AWS, you will need to ensure that you are up to compliance for whatever standards and regulations your business is specifically held to. If you run software that deals with consumer data in the EU, you would need to make sure that you are in compliance with GDPR. Or if you run healthcare applications in the US, compliance have already been completed, and you can focus on meeting compliance within your own architectures that you build on top of ports. Since you aren't running the data center yourself, you can essentially request that AWS provides you with documentation proving that they are following best practices for security and compliance. One place you can access these documents is through a service called AWS Artifact. With AWS Artifact, you can gain access to compliance reports done by third parties who have validated a wide range of compliance standards. Check out the AWS Compliance Center in order to find compliance information all in one place. It will show you compliance-enabling services as well as documentation like the AWS Risk and Security White Paper, which you should read to ensure that you understand security and compliance with AWS. To know if you are compliant in AWS, please remember that we follow a shared responsibility. The underlying platform is secure, and AWS can provide documentation on what types of compliance requirements they meet through services like AWS Artifact and white papers. But beyond that, what you build on AWS
DDoS, DDoS, the distributed denial of service. It's an attack on your enterprise's infrastructure. You've heard of it. Your security team might have written a plan for it. You know that many businesses have been devastated by it. But what exactly is in a DDoS attack? It is based on the helpful parts of the internet, like the National Weather Service. The capacity of your entire front end with almost no is scalable, and how it runs at the region level to proactively help defend your system against an ever-growing list of destructive vectors. All right, that's it. The clock is almost up. The takeaway is a well-architected system is already defended against most attacks. And by using AWS Shield,
with all the comings and goings on in your coffee shop, you'll want to increase security to your coffee beans, equipment, and even money in the till. For your beans, this could be when they're sitting in your storeroom or even when you're transporting them between shops. After all, we don't want unwanted visitors with access to our coffee beans or even running off with precious equipment. To start off, let's chat about how you can secure your coffee beans or your data, whether it's at rest or in transit. For our beans, the simple way to do it would be to lock the door when we leave at night. That's the notion of encryption, which is securing a message or data in a way that can only be accessed by authorized parties. Non-authorized parties are therefore could be a client accessing the services, vulnerabilities, and offering, known as Amazon Guard Duty. It analyzes continuous streams of metadata generated from your account and network activity found in AWS CloudTrail events, Amazon VPC flow logs, and DNS logs. It uses integrated threat intelligence, such as known malicious IP addresses, anomaly detection, and machine learning to identify threats more accurately. The best part is that it runs independently from your other AWS services, so it won't affect performance or availability of your existing infrastructure and workloads. There are so many other security services, like Advanced Shield.
All right, it's time to break down what we just covered. First things first, AWS follows a shared responsibility model. AWS is responsible for tools and permissions as well as use the least privilege principle when scoping permissions for users and roles in IAM, encrypt your data at every layer, both in transit and at rest, and make sure you use AWS services to protect. As the owner of the coffee shop, I want to watch what's going on throughout the day, making sure things are running smoothly. In the coffee shop, I can see people are getting their coffees, and things look generally fine. But I can't just sit there and watch things all day long. I would like to eventually leave and maybe come back at the end of the day and be able to check in and see how the shop did when I was gone. For example, I might want to know how many coffees were sold today. How long was the average wait time for someone when ordering a coffee? Did we run out of inventory for anything today? Even better yet, I'd love to be able to be automatically alerted if the wait times become too long. That way, I can call in another employee or go pitch in myself. Every business, including this coffee shop, can use metrics to measure how well systems and processes are running. This idea of observing systems, collecting metrics, evaluating those metrics over time, and then using them to make decisions or take actions is what we call monitoring. It's important to set up monitoring in the cloud. With the elastic nature of AWS services that dynamically scale up and down, you'll want to keep a close pulse on your AWS resources to ensure that your systems are running as expected. For example, if an EC2 instance is being overutilized, you can trigger a scaling event that automatically would launch another EC2 instance. Or if an application starts sending error responses at an unusually high rate, you can alert an employee to go take a look at what's going on. In the next few videos, we will cover a variety of tools that help you monitor your AWS environment. This monitoring will help you measure how your systems are performing.
Now we're making lots of coffee, serving customers, and everything seems to be going spiffy in our coffee shop. But as we run espresso machines more and more, use mugs, constantly open and close the fridge, we want to be able to make sure we're alerted to something which might have gone awry. Maybe an espresso machine needs to be cleaned or repaired. The point is, as a business owner, you need visibility into the state of your systems. Are things running well? Do you see a degraded customer experience? Are you frequently delivering the wrong drink to customers? Or is everyone getting their orders as expected? You have all sorts of questions about the success of your operations, and the same idea applies to systems built on AWS. You need a way to monitor the health and operations of your solutions. Luckily, then send an SMS to the manager to say, clean the machine. You can create all sorts of custom alarms for metrics from all different types of AWS resources. Now, what if we want to aggregate all those metrics in a single pane of glass? Well, we can use CloudWatch's dashboard feature. Think of a dashboard as a screen which lists out metrics in near real time. In our case, we can create a CloudWatch dashboard which will show us all our espresso machines and their espresso counts so we can proactively monitor them. These dashboards would auto-refresh when they are open so we can see an up-to-date view of our resources. Finally, what are the benefits of using a service such as CloudWatch? Well, the first one is that you can have access to all your metrics from a central location. This enables you to collect metrics by, for example, aggregating usage across an entire fleet of EC2 instances to derive operational and utilization insights.
The cash register, one of the world's first self-auditing devices. The principle is simple: trust but verify. You have your entire store being run by a clerk that you trust, but you want to make sure that the cash in the
and say, hey, this process should be streamlined. Or, hey, I have some good tips on how to save money on your overhead. Or even, hey, I noticed I was able to waltz right in, go behind your cash register, and open the drawer without anyone noticing. Not good. The point I'm trying to make is sometimes it's nice to have someone who knows the industry best practices and knows what to look for come in and tell you what you need to change in order to run more efficiently, be more secure, or to save some money. AWS has an automated advisor called AWS Trusted Advisor. This is a service that you can use in your AWS account that will evaluate your resources against 5 pillars. The pillars are cost optimization, performance, security, fault tolerance, and service limits. Trusted Advisor in real time runs through a series of checks for each pillar in your account based on AWS best practices. And it compiles categorized items for you to look into, and you can view them directly in the AWS console. Some checks are free and are included in your AWS account, and others are available depending on the level of your support plan. Some examples of checks are, if you don't have multi-factor authentication turned on for your root user, it's going to let you know. If you have underutilized EC2 instances that might be able to be turned off in order to save money, or if you have EBS volumes that haven't been backed up in a reasonable amount of time, it will let you know that too. To get a better idea, let's look at AWS Trusted Advisor in my own account. I'm already logged into the console, and I'm going to type in Trusted Advisor into the search. This brings me to the Trusted Advisor dashboard, and I'm going to click on the cost optimization pillar first to view what it has found. You can see right away there are 3 levels of items it is showing me. There is the red circle, which means action recommended level. This means that my EC2 instances are not properly launched across AZs. So if one AZ has trouble, my application might incur an outage. Deploying across AZs would be the answer to this one. Finally, let's check out service limits. This pillar will tell you when.
Understanding what is happening in your environment is key to maintaining efficient, secure, and compliant applications. We discussed how CloudWatch can provide near real-time understanding of how your system is behaving, including being alerted to conditions that require your attention. CloudWatch also gives you the ability to look at those metrics over time as you tune your system for maximum performance. We discussed how CloudTrail can help you know exactly who did what, when, and from where. It answers all of your AWS auditing questions, except why they did it. And finally, we looked at Trusted Advisor that compiles a quick dashboard of over 40 common concerns around cost, performance, security, and resilience in an actionable dashboard. There are, of course, many additional monitoring and analytical tools available for your use, but this will help you get a good feeling for some of the variety. Well, now that Morgan is the owner of the coffee shop, she probably has a lot of logistics to worry about, as well as all the costs that come with this added responsibility. Costs like the building lease, the tables, the cost of the employees, of course. What about taxes? What about power and heating? In order to get the exact report, now, spoiler alert, AWS provides a lot of free tools to help you plan and analyze your budgets for your.
So you've created a brand spanking new AWS account and want to get started, but you're worried about exhausting your credit limit. Well, don't worry. If you're looking to try out some AWS services, you might be able to try them out under our free tier. Depending on the product you're looking at, the free tier offers 3 different ways to try out a service. Number 1, always free. That means a service is available to all AWS customers, and the free tier does not expire. Number 2, 12 months free. That means you have 12 months to try out a service following your initial sign-up date to AWS, so the date you created your AWS account. And number 3, trials. Some services offer a short-term free trial, and then they expire after that period ends. Simple enough, right? Let's illustrate with a few examples. Let's take AWS Lambda, our serverless compute option. As of March 2020, it allows for 1 million. The free tier are SageMaker, Comprehend Medical. Hey there, AWS aficionados. Are you like me and curious about billing information of your AWS account? Well, let's walk through a demo so you know where to go. As you can see, I'm already logged in, and now we're going to search for billing and click the option that shows up. And boom, with that, you already have some useful information. You can see your month-to-date spend on the right-hand side with the top services being used. Below on the left is the last month, current and forecasted amounts. Below that is the top free tier services by usage. You even get to see the costs broken down by region. And for global services, we see them broken.
When you own multiple coffee shops around the city, like we talked about before, each one will have its own expenditures and its own profits. At the end of the day, for these coffee shops, they're all owned by the same entity. Because of that, the money is flowing to and from one main account. If there's a coffee machine repair person on call to help fix the coffee machines when they break, that repair person will bill the organization, not the individual coffee shop. Okay, let's take that idea and apply it to AWS. A singular company will more than likely have multiple AWS accounts. And as you already learned, you can manage multiple accounts in AWS by using AWS organizations. One of the lovely features of AWS organizations is called consolidated billing. At the end of every month, instead of having to pay an AWS bill for every single account, you can roll those bills up into one bill owned by the owner of the organization. This makes it easier to keep track of your bills. You don't get 100 bills if you have 100 AWS accounts. Just like our coffee shop example. If my repair person visited 11 of my coffee shops repairing coffee makers, they would just make one bill for the billing cycle, so it's easier for the company to manage. Same idea with the consolidated billing feature for AWS organizations. You can still view your AWS bill in an itemized fashion, so you know which account spent what, but it all goes into one central location for ease of viewing. There are other benefits of using this feature too. One of them is that the usage for AWS resources is rolled up to the organization level. AWS does offer bulk pricing. Each individual account may only have a small amount of usage, but you can get the bulk discount pricing because of the aggregate across all accounts in the organization. In addition, if you have a savings plan in place, or if you are using reserved instances for EC2, it can be shared across AWS accounts in the organization. The best part about this is that the feature is free and easy to use. So it simplifies the billing process, lets you share savings across accounts, and doesn't cost you any extra money. Nice.
If you're going to exceed your budgeted amount for resources. So let me show you what I'm talking about here with the demo. To get started, you navigate to the billing section of your AWS console. Click Budgets, then click Create Budget. Choose a type for your budget. I'll pick Cost. Give your budget a name. Enter an amount, let's say 1,000. Now let's add an email address. Gotta make sure to blur this out, folks. I get enough spam as it is. Now we click Confirm Budget and Create. And voila, we have our first budget. How streamlined was that? I think it's safe to say we budgeted our time wisely in that demo.
As we have already discussed, AWS has a variable cost model, and you only pay for what you use. You don't have one fixed billed amount at the end of every month. Instead, it fluctuates with the resources you use and how you use them. To be grouped by different attributes. And I'll go ahead and select region. I can group by other attributes as well. One important grouping to note is to group by.
One of the great things about AWS is no matter how big or small your business is, you're never alone. From small startups to large enterprises, private sector and public, all businesses have support options available that are designed to fit your specific needs. To begin with, every customer automatically gets AWS basic support. No cost at all. Any customer can access support functions like 24/7 access to customer service, documentation, white papers, support forums, AWS Trusted Advisor, and the AWS Personal Health Dashboard. It's a personalized view of the health of AWS services and any alerts when your resources might be impacted. These functions are free for every production system is impaired, and what comes with enterprise level support. They specialize. AWS support looks at the customer holistically, not just. Another huge way that AWS supports your enterprise is through the AWS Marketplace. The AWS Marketplace is a curated digital catalog that streamlines your steps to find, deploy, and manage third-party software running in your AWS architecture, all while providing a range of payment options. And this allows you to accelerate innovation while rapidly and securely deploying a wide range of solutions, while also reducing your total cost of ownership. To help us understand this more, I want to talk about what the AWS Marketplace brings to the table and how it can help you improve your speed and agility with AWS. The first key way that the AWS Marketplace helps customers is that instead of needing to build, install, and maintain the foundational infrastructure, you to use any annual number of enterprise-focused features, such as custom terms and pricing, where you can manage custom licensing agreements, a private marketplace.
Well, you've heard a lot about pricing and support, and it's probably a lot more than you initially thought. You learned about the pay-as-you-go nature of using AWS cloud resources. We discussed the difference between on-premises and cloud costs, and we even showed you how you can get your feet wet with the free tier offered with most AWS services. We talked about how AWS organizations can be used and how it can help you with consolidated billing of multiple AWS accounts. We covered AWS budgets, Cost Explorer. We even explored AWS console billing so you could get familiar with it, and then switch gears to talk about the different support models offered on AWS. Very handy if you're looking for assistance on your cloud journey. Speaking of assistance, we introduced you to the expansive AWS partner ecosystem so you can find partners to help. So it looks like we've established how to get going on the AWS cloud, but what if you have existing deployments in on-premises environments or have started a cloud journey without AWS? Well, we'd love to help you move across, especially since you can take advantage of some real savings by moving. This brings us to migration and innovation. We'll show you all the options from migration tools, the AWS Cloud Adoption Framework, and even the Snow family, which are physical devices to migrate data in and out of AWS. So before we adjourn, stay glued to your seats for information on how to move from on-premises environments or the cloud to AWS.
Migrating to the cloud is a process. You don't just snap your fingers and have everything magically hosted in AWS. It takes a lot of effort to get applications migrated to AWS, and having a successful cloud migration is something that requires expertise. Luckily, many people have had successful cloud migrations in the past, and you're not the first one to have solutions in AWS. Because of this, a lot of the knowledge around how to go about hosting on AWS has been captured and shared. That being said, what position you hold in your organization will impact the things that you need to know or help with for your migration. If you are a developer, your role and viewpoint will be much different than a cloud architect, business analyst, or which focus on the technical capabilities. Someone who is a business or finance analyst would fall under the business perspective. HR would fall under the people perspective, and a cloud architect would fall under the platform perspective. Each perspective is used to uncover gaps in your skills and processes, which are then recorded as inputs. These inputs are then used as the basis for creating what's called an AWS Cloud Adoption Framework action plan that you then use to guide your organization's change management as you journey to the cloud. Having an action plan that makes sense for your organization can help keep you on track. Migrating to the cloud can be complicated, but again, you're not alone in this. There are tons of resources to help you get started, and the Cloud Adoption Framework is a great place to look.
So it is finally time to migrate from your on-premise optimized and efficient. But it doesn't work that way. Every application, or application groups if they're tightly coupled, will have 6 possible options when it comes to your enterprise migration. We call these the 6 R's. Once you've gone through the discovery phase and know exactly what you have in your existing environment, you decide which option among the 6 R's is the best fit based on time, cost, priority, criticality. The first option is rehosting. This is otherwise known as lift and shift. And this is an easy thing for businesses to do because you're not making any changes, at least not at first. Just pick up the applications and move them pretty much as is onto AWS. You may not get all the possible benefits, but some companies found that even without any optimization, they could save up to 30% of their total costs just by rehosting. Also, we find it's easier to optimize applications later once they already live in the cloud, because your organization has better skills to do so. The hard part, the migration, is already complete. The second option is called replatforming, or lift, tinker, and shift. It's still basically a lift and shift, but instead of a pure one-to-one, you might make a few cloud optimizations, but you're not touching any core. They still need to run, but don't turn them off for another 3 months or 8 months. Or these apps could be migrated to AWS, but why? You should only migrate what makes sense for your business. And then as time goes on, these applications can be deprecated where they live and ultimately retired. Okay, let's get back to what is going to move to AWS. Number 5.
Some of our customers need to get data to AWS, and most of them would like to do it in an efficient and timely manner. The usual route is to simply copy the required data over the internet, or better yet, if they have a direct connect line. However, with the limitations of bandwidth, in general, this can take days, weeks, or even months. For example, a dedicated 1 gigabit per second network connection theoretically moves 1 petabyte of data in about 100 days, and in the real world, likely longer and at a higher cost. With this customer feedback, and as a way to address this gap, we therefore introduced the AWS Snow family of devices. The first device, which is also our newest offering, is called AWS Snow Cone, and it's a device that holds up to 8 terabytes of data and contains edge computing. Edge computing options are Amazon EC2 instances and AWS IoT Greengrass. To obtain one, you place an order via the AWS Management Console. We ship it to you, you plug it in, and copy your data, and finally ship it back to us. We'll then copy the data to your AWS account, usually an Amazon S3 bucket that you own, and boom, Bob's your uncle, and your data is available to use. Customers usually use these devices to ship terabytes of information, such as analytics data, video libraries, image collections, backups, and even tape replacement data. I mean, who doesn't have a terabyte collection of cat images that they want to back up to the AWS cloud? But what if 8 terabytes is not enough? Well, good news. We have a product for that requirement called Snowball Edge. It comes in 2 versions, a Snowball Edge Compute Optimized option and a Snowball Edge Storage Optimized option. Even better is that they fit into existing server racks and can be clustered for greater computing needs. Once you plug them into your infrastructure, you can even run AWS Lambda functions, Amazon EC2 compatible AMIs, or even AWS IoT Greengrass to perform simple processing of data right then and there. Customers and tamper resistant while on-site or in transit. This means the hardware and software is cryptographically signed and all data stored is automatically encrypted using 256-bit encryption keys, owned and managed by you, the customer. You can even use AWS Key Management Service to generate and manage keys. As always, it's been a pleasure taking you through yet.
There's so much more that can be done on AWS that we have time to talk about here. For example, when it comes to migrating onto AWS, we didn't even cover running VMware on AWS. The same VMware-based infrastructure that you use on-prem can, in many cases, just be lifted up and dropped onto AWS via VMware Cloud on AWS. And this is just one of many concepts that make AWS a place where builders go to create and innovate at the pace of their ideas. When it comes to machine learning and artificial intelligence, AWS has the broadest and deepest set of machine learning and AI services for your business. You can choose from pre-trained AI services for computer vision, language recommendations, and forecasting. Amazon SageMaker can quickly build, train, and deploy machine learning models at scale, or build custom models with support for all the popular open source frameworks. Our capabilities are built on the most comprehensive cloud platform, optimized machine learning with high-performance compute, and no compromises on security and analytics. Tools like Amazon SageMaker and Amazon Augmented AI, or Amazon HUI, provide a machine learning platform that any business can build upon without needing PhD-level expertise in-house. Or perhaps ready-to-go AI solutions like Amazon Lex, the heart of Alexa.
Hello, Blaine. What can I help you with?
Helps you build interactive chatbots. Or what about Amazon Textract, extracting text to use AWS Ground Station and only pay for the satellite time you actually need. I could go on for days talking about all these new technologies, like literally for days. AWS Training Certification offers training classes on many of these technologies already, and every month, AWS seems to release something even better for us to talk about.
Over the last few videos, you started to learn about migration to AWS, as well as some interesting and innovative services you can use to either aid in your migration or to step your game up with AWS. You learned about the AWS Cloud Adoption Framework. The Cloud Adoption Framework gives you guidance on who to loop into a cloud migration, what their roles are, and the sorts of things that they should be focused on. There's the business, people, and governance perspectives for non-technical planning, and the platform, security, and operations perspectives for technical planning. We also talked about the 6 R's of migration. The R's represent different strategies on moving solutions to the cloud. They are rehost, replatform, repurchase, refactor, retire, and retain. They're also more secure than using high-speed internet. We've covered a lot of different AWS services in this course. And as you know, you use each individual service as building blocks for your solutions. There are endless architectures you can create to solve whatever problem you are trying to solve on AWS. You can string together services in a simple or complicated manner. Having a lot of options is great, but how do you know if the architecture you've created is, well, good? Let's look at this basic 3-tier architecture. Does this look good? Well, we have a load balancer, some instances, and a backend database. Seems all right to me. But what about this alternate architecture? This architecture has now been replicated across availability zones, or AZs. This is important for reliability. If one AZ is a tool you can use to evaluate the architectures you build for excellence in a few different categories.
The well-architected framework is designed to enable architects, developers, and users of AWS to build secure, high-performing, resilient, and efficient infrastructure for their applications. It's composed of 5 pillars to ensure a consistent approach to reviewing and designing of architectures. The first pillar is operational excellence and focuses on running and monitoring systems to deliver business value and with that, continually improving processes and procedures. For example, automating changes with deployment pipelines or responding to events that are triggered. Second is security. And as you know, security is priority number 1 at AWS. And this pillar exemplifies it by checking integrity of data and, for example, protect. It kind of looks like a server side. You could then lower costs by choosing a more cost-effective size. In the past, you'd need to evaluate these against your AWS infrastructure with the help of a solutions architect. Not that you can't and aren't still encouraged to do that, but we listened to customer feedback and decided to release the framework as a self-service tool, though we'll architect whether the question is applicable or not. This is important as it affects your overall score. Oh, and I can't forget section 7, where you'll be presented with short videos explaining how to answer a particular question. Anyhow, that's the well-architected framework and tool. Hope you've enjoyed learning how to evaluate your workloads.
All right. So now you've learned all there is to know about AWS, and you're ready to go build your empire, right? Okay. So even if that isn't true, you should still now have a good understanding of a lot of the different services AWS has to offer, and how you can use them together like building blocks to build solutions for your business that scale, are flexible, and are reliable. You also should by now understand some of the terminology AWS uses. Knowing this terminology is important for moving forward with your cloud journey. As you read blog posts or AWS documentation, you now should know a lot of the acronyms and phrases that you'll see. What you should also keep in mind as you move forward is the 6 main benefits of using the AWS cloud. You'll start to evaluate what applications and solutions will be built in the cloud, and knowing these benefits can really help you make those decisions in an informed way. Let's start with the first benefit.
This is a super important thing to remember. When you are building traditional on-premises data centers, you need to invest a large amount of money up front just to get started. You need to invest cash into the actual data center physical space, all the hardware, the staff for racking and stacking that hardware, and the overhead of keeping the data center running. For a medium to large business, this can be hundreds of thousands or millions of dollars. Then, no matter what your utilization is of that data center, you have a fixed cost, and consider your budget around that fixed cost. Billing with AWS is fundamentally different than the traditional billing model we just talked about. Your bill with AWS will be variable month to month as you consume more or less resources. Now, the great thing about this is if you are just getting started, there's no need to come up with $1 million to invest into your AWS environment. Instead, you can start small, get billed for only what you use, and as you use more resources over time, your bill will fluctuate with that growth. Now, if your bill gets out of your allotted budget, you can find ways to save money by turning off unused instances, deleting old resources that aren't being used, optimizing your applications, using tools like AWS Trusted Advisor to help you find opportunities to save money. Just because your bill is high one month, it doesn't mean you can't get it lower the next month. And that's just not true with traditional on-premises data center billing. That's the first advantage. The next is
Benefit from massive economies of scale. This one is straightforward. AWS is building out massive amounts of capacity all around the world, and in order to build all those data centers, AWS is buying huge amounts of hardware. AWS is also an expert at building efficient data centers. We can buy the hardware at a lower price because of the massive volume, and then we install it and run it efficiently. Because of these factors, you can achieve a lower variable cost than you could running a data center on your own. Next up is
stop guessing capacity. When you are building out a traditional data center, you need to estimate how much capacity you will need to run your business. Let's say you estimate you will have a user base of 10 million people over the next 3 years. You purchase enough hardware to support that growth over time. And then turns out you only have about 500,000 users, much lower than you anticipated. Well, guess what? You are still stuck with that cost and hardware for the 10 million users. You overestimated your capacity. The other side of the coin here is that you estimate your capacity too low, and you now need to scramble to build out your data center to handle the higher capacity before your customers have a degraded experience or before you lose customers altogether. That takes time, and you most likely won't keep up, or you will have to put in a heroic effort to achieve it. Guessing your capacity up front can be problematic if you either over or underestimate. With AWS, you don't need to guess your capacity. Instead, provision the resources you need for the now, and then use the scaling mechanisms for each resource to scale up or down based on the real-life capacity it needs from day to day. As scaling can take minutes with AWS instead of weeks or months with on-premises resources. The next is my personal favorite benefit.
increase speed and agility.
last but not least, we have
Go global in minutes. Let's say you're a company based in the US, and you want to expand your operations to Germany. You have data centers in the US serving this region, but you'll need data centers in Germany to serve that region. Traditionally, you need to have staff in Germany running and operating a data center for you. With AWS, you can just replicate your architecture to a region in Germany. And if you're set up correctly, you can do this in an automated fashion using tools like AWS CloudFormation. The time it takes for you to expand into a secondary area of the world traditionally can be months or years. With AWS, it just takes minutes.
That's it. Those are the 6 main benefits of using AWS. From all of us AWS